Hello children, welcome to LUCID Study and Mathematics class. Today we are going to discuss the chapter Applications of Trigonometry. Okay, so as the name says that Applications of Trigonometry, so let us recall trigonometry once and then listen to this class. It will be easy for us. Okay children, so before learning this chapter, please be thorough with the trigonometry chapter, and this chapter is very easy. So it is depend on your basic formulas of trigonometry. Okay, so let us enter into this chapter. Now see, this is the Leaning Tower of Pisa right now. So what is the height of this Leaning Tower of Pisa? Can you imagine how we can find the height of this tower? So it is very easy, right? One person will stand on the top of the tower and he will leave a rope, and after that they will measure the rope. Sorry, I am joking. So it is not like that. It is by using trigonometric concepts, we have to find the height of trigonometry. Similarly, see the London Bridge. London Bridge also, it is very long. Okay, so how to measure the length of the bridge? Here also we have to apply trigonometric ratios to find such long distances. Now you understood what we are going to learn in this chapter, right now? Some more I will show you. See here, this is Mount Everest. So how to find the height of Mount Everest? So all these we are going to learn in this chapter. We understood what we are going to learn in this chapter right now. So let us know the basic concepts of this chapter. Very important this. See, the first statement is a line of sight. So what do you mean by line of sight? Suppose I am observer. Suppose you went to see the Pisa Tower, Leaning Tower of Pisa, you went and you want to watch it. You want to watch the top of the tower, a tip of the tower. So how you will watch? So you will raise your eyesight and you will see. Okay, where you will see? Directly you will see the tip of the tower. So the light ray which connecting to your eye as well as the thing what you are observing, that ray is said to be your line of sight. Okay, see here, suppose this person is observing the top of the tree. So from his eye to this top of the tree is the line of sight. Okay, next one, angle of elevation. So if you are observing any object that is more higher than you, so then there will be angle of elevation. Okay, so angle means degrees we will measure, we know this, right? So any object which is taller than you or higher than you, so you will see that top of that object by lifting your eyes little bit higher, right now. So that whatever connecting ray, light ray, is said to be your line of sight. Okay, so the angle made with the earth, see, this is the earth, suppose this is the line of sight, you are observing this. So here you are observing the object which is taller than you or higher than you. So here this angle is said to be your angle of elevation. Okay, next one more. So one boy is standing on Eiffel Tower and he is observing a boy who is walking on the ground. So how he has to see to him? So he has to see him by getting down his eyesight. So see, this boy is watching this boy like this. So here this is the line of sight. Now this is the line which is parallel to the ground. Okay, parallel to the ground. Suppose this is the earth. So he is observing this boy. Okay, this is the line parallel to the point of observation. From here, if you draw a line parallel to the earth, the angle made by line of sight with this is called angle of depression. Angle of depression means if you are to see the objects which are lower than you, okay, shorter than you, then we will go for angle of depression. Okay, now if you observe here, this is the boy. Suppose if I draw a line parallel to the earth here, suppose this boy is watching to this boy. Okay, he is observing him, he is observing him. Now this boy is having angle of elevation. This is the line of sight for both. Okay, so this angle is said to be angle of elevation. Right now he is observing the boy who is more heighter than him. So this is angle of elevation. Now see, this is parallel to this one and this one is also parallel to this one. That means all three are parallel lines. Now see, these two angles are alternate interior angles. Am I right? These two are parallel lines. These two are alternate interior angles. So they are equal. We know that. If two lines are parallel, this is the transversal. Then these two angles are alternate interior angles. Both of them equal. See, the angle of depression at this point is equal to angle of elevation at this point. Suppose the angle of depression is theta. Now this is the angle of elevation for this boy. This is also will be theta. Angle of depression is equal to angle of elevation at that point. Okay children, this is what we need to understand, right? Okay, how to measure the angle? So how we will measure the angle? Suppose if I want to see the top of the tree, so how much angle I have to watch so that the top of the tree I can see how to measure it. So there is a specially designed apparatus, that is a Theodolite. What we will call? Theodolite we will call. See, Theodolite will be like this. So you will watch from that side. So it will move like this. See. So if you move here, what happens? This is the angle. It will show you like protractor shape. It will be there. So here all angles will be measured. Whenever you move like this, you can see the reading over here, how much angle you are watching to the top of the tree. Okay, very important. Okay, so this is the Theodolite. So with this you can identify how much angle you are observing. Okay.